Hello everyone, and thank you for attending today's webinar, The State of SDN Deployments and How Converged IP Optical Control Can Shake It Up, sponsored by Sedona Systems. Before we begin, I wanted to cover a few housekeeping items. On the right-hand side of your screen is the Q&A. If you have any questions during the webcast, you can type your question into the Q&A box and submit your questions to our speakers. All questions will be saved, so if we don't get to answer you today, we may follow up via email. At the bottom of your audience console are multiple application widgets you can use. If you have any technical difficulties, please click on the yellow Help widget. Here you can find answers to common questions. A copy of today's slide deck is available for download in the green Resource List widget. Towards the end of today's presentation, we'll ask for your feedback. A survey will pop open on your screen and will only take 1 minute to complete. Your feedback is extremely helpful. An on-demand version of the webcast will be available about 1 day after the event and can be accessed using the same audience link that was sent to you earlier today. I'd now like to turn the event over to Heavy Reading Senior Analyst, Sterling Peck. Sterling?
Hi. Yeah, thank you, Hannah. Hello and welcome everybody to today's webinar, State of SDN Deployment and How Converged IP and Optical Control can Shake It Up. I'm Sterling Perrin. I'm a Senior Analyst with Heavy Reading, and I'll be your moderator for today, and I'm very happy to be joined by Ori Gerstel, who is the founder and CTO of Sedona Systems. Hi, Ori, and welcome to the webinar.
Hi, Sterling. Pleasure to be here.
Great. Looking forward to what you've got to say, and I'm sure the rest of the audience is as well. So for everybody, here's a look at the agenda for the next hour. I will start off with some heavy reading research I've done on this topic on the value of IP and optical integration in the era of SDN. And then Ori will take those other bullet points, what's slowing SDN deployment, different deployment models, and then he'll lay out an evolutionary path to SDN. And then we'll have Q&A at the end. We should have about 10 to 15 minutes for your questions. And then also we've got 2 interactive poll questions on this one following my presentation and then one at the end. So please stay tuned and participate in those. I did want to start with some definitions to make sure everybody understands we're talking about kind of the same things here. So carrier SDN, the way Heavy Reading defines it, is the application of SDN in the carrier wide area network to layer 0 up through 3 of the OSI stack, so optical up through the IP layer. One point I want to make on this slide is in the very early days of SDN, it was synonymous with open flow protocols specifically. That's not the case anymore. And so when we look at SDN, if you look at those 5 bullet points, if the software can meet these requirements, we are considering it as SDN. So the software programmability, this global network view, APIs and application-centric capabilities, the ability to provide network abstraction layer, and then openness of software, which of course relates back to the open APIs. Those are the things we look at. Another point I'll make here is there's also a lot of talk in SDN and white box. Those are not the same thing either. For us, white box is really the application of NFV, and so an SDN and an NFV environment would be white box, but there's also quite a bit of SDN that's not related to NFV, and that's really where we're going to focus today. The second definition on the bottom there is transport SDN, which is a subset of overall carrier SDN, and so that's the application of SDN specifically to the optical layers, layer 0, the photonic layer, and layer 1. And so that's an important distinction we make, optics, and then the higher layer, layer 2 and layer 3 kind of being separate with different requirements. Initially, when we started researching carrier SDN, we expected optics would be pretty much near the top in operator priorities, but what we saw through different iterations of surveys is that optics, when we asked about priorities for SDN, was actually toward or at the very bottom. And often by a very large margin. So then we started asking the question by coupling the IP and the optical layers together as IP and optical integration, which is what this operator survey slide shows. And we've asked this multiple ways, and we get similar results. But when we combine the IP and optical layers together, the priority rises actually to the very top or very close to the top, as in this case on the slide. And so the key takeaway we've gotten from kind of these different iterations of questions is that the value of the optical layer in SDN is its interoperability and interaction with the IP layer. And then, of course, SDN in this case is the glue that ties together those layers, and that really is where the focus is. I've been showing this slide a bit this year. As I started looking at IP and optical integration, obviously this technology has been around for a long time, actually the 16 years that I've been in the optics industry and probably a bit longer than that. And so I wanted to kind of understand why things didn't really take off. But it was an interesting exercise to pull together these different publication headlines from way back earlier in my career, seeing that really at the very beginning IP and optics was a big deal, and it seemed like it was going to take off at any point. So there was a lot of focus on interoperability, the OIF, and the GMPLS standard for software control was really seen as the way to tie together these IP and optical layers, and there were these massive demonstrations at the Supercom trade shows through the years, if folks remember. But despite the demonstrations, the technology really never made it into commercial application in a big way, and so there were some big problems, and I've traced out three major ones, which are bulleted here on the slide. The lack of a demonstrable business case for IP and optical layer integration was definitely a very big one, and I think if that had been tackled a bit better in the early days, maybe some of the other things would have been addressed more quickly, but we never really saw the business case proven out in a way that operators fully understood it. There was also a hardware problem in the early days, and so if you're looking at tying together IP and optical layer, you had a flexible IP layer, but the photonic layer, even in the early days of ROADMs, was not very flexible. Those endpoints were fixed, and so really limited what you could do to reconfigure an optical layer, which meant that the business case for IP and optical integration suffered quite a bit just from that hardware limitation. And then the third, and it's last but not least, is viable interoperability standards. I talked about GMPLS as a standard to tie together IP and optics, but the reality is it was a very loose standard, very nebulous, I guess, in some respects. And so these demonstrations that were put on for Supercom, I think they were every other year. It took a massive amount of work to really drive that interoperability, even if vendors were standards compliant. So the optical to optical standardization was not there, and the IP to optical standardization was not there. So IP and optical integration really kind of was just left in demonstrations and kind of lab work, but not really commercial implementation. On this slide, I want to address the business case. I think these two operators, Telefonica and Deutsche Telekom, have done a really excellent job of showing what the value of IP and optical layer integration is. And I've been following their work for some years. And so 2 points I'll make on this slide. One of them, which I think was really significant, while much of the industry focused on the OpEx benefits of tying together optical and IP layers, these operators focused really from the very beginning on CapEx benefits. And I think that was a really smart way to go about it, because CapEx benefits are concrete. They're concrete numbers, and they can really be applied from one to another, whereas the OpEx has always been very difficult to quantify, even for a single operator. And then when you go to apply OpEx to other operators, it becomes more difficult. People have different pay structures, organizations, et cetera. So focusing on CapEx, and then if you can prove the CapEx, then you can start to look at the OpEx. But without the CapEx, what we found is it's very hard to prove in these technologies. So they focus on CapEx. The second really important point is that their work predates SDN as a term, at least. What happened is in their work, they realized there was a critical role for a software glue to be standardized and tie together the layers. As SDN started to evolve as a term, then it became obvious that software glue is SDN, but they did predate SDN. So if you look at the chart here on the right, what they did is they showed CapEx benefits of using multi-layer control over a 5-year period, and they had different scenarios. So the blue is the baseline, that's the PMO, and then they looked at a multi-layer bypass Multi-layer bypass optimization, which is really router bypass is another term for it. So if you can bypass those intermediate routers. Then if you go to the green one, that was a multi-layer restoration application from an optical layer failure. And then the last incremental bit to get to purple there was if you also added multi-layer restoration from an IP failure. So this was specifically this was looking at the core network. And if you use all of those different applications together, you could see 58% CapEx reduction in the case of Telefonica, 62% in Deutsche Telekom. So actually quite similar as they looked at their core networks. The one, I guess, issue with this work that they did is it addressed the value of IP and optical, but it didn't address the multi-vendor. It was this in particular case was pretty much a single vendor approach, primarily a Cisco-centric approach. So for both of these operators and many others, the value is great, but it needs to be multi-vendor. And so from there, kind of their work is focused on how do you get to a multi-vendor ability to do something that's quite similar to what was shown there. And that kind of brings us up to date in terms of where we are with multi-layer, multi-vendor, IP, and optical. This slide is a continuation of that work, and it is showing the ability to do multi-layer and multi-vendor IP and optical control, including that restoration application which drove so much CapEx savings. This demonstration here was hosted by Telefonica's lab, and it was shown at the OFC show in March of this year. And as I said, it really does bring us up to date in terms of where we are. So it was multi-vendor. So the vendors here, you can see Cisco, Nokia, Huawei, participating on the routing layer, Adva, Coriant, and also Huawei again on DWDM. And then the multi-layer software orchestration was provided by Sedona Systems in this case. And Ori, of course, will talk more about this class of software and what it does. But it was used in this particular case. And so they showed multi-layer restoration planning, multi-layer restoration execution, and then a hitless revert after an optical failure was fixed. So, and the critical thing is tying these together with multi-vendor. And then I think probably the second key point is that it didn't take 2 years to put together. I think it was measured in months as opposed to years or maybe even shorter, or he can chime in on that when he speaks. But it was a very quick way to go about tying together a bunch of vendors. So that's where we are today. I'll leave it at that. I'll let Ori and Sedona talk through kind of an elaboration of the different paths to get to this type of an application in multi-vendor and multi-layer. But with that, before I bring Ori in, let's jump right to our first poll question. And so this should be up for everybody on the slide now. The question is, what is the main challenge for service providers in deploying SDN in service provider networks? So this is a pick one. There are many challenges. I've talked through some of them. Lack of standards, lack of a business case, complexity to deploy, and then lack of commercial solutions. So I'll give a moment for everybody to weigh in on that as I wait for some responses to come in. Ori, while we wait, just a quick clarification on that demonstration I just talked through. Do you happen to know the amount of time that it took to put that particular one together? I know it was a lot quicker than 2 years, but I don't have the exact.
Yes. It took literally for the specific multi-layer application to be built a few months. It's really amazing what big of a difference it makes to kind of do things in centralized modern software rather than to do it in a distributed way on kind of real-time systems. So pretty amazing.
Okay, right. That's what I suspected. That was really one of the key problems with the old way is just the massive amount of time. So it looks like we've got. Let me push this out to the audience. See where we are. Just do another push. So Ori, you should also be able to see this on your screen. Complexity to deploy coming in number one, about 35%, and then a tie for business case and lack of standardization, a lack of commercial solutions at the bottom of the barrel there. Let me do one last push. Doesn't look like it's changing. Any surprises in that? Did you expect complexity would be the biggest challenge?
Yes, it's exactly what I expected. Indeed, a lot of my talk centers around how to make it easier to deploy, how to make it valuable. It also ties into the lack of business case aspect. How do make the business case work every step of the way? So very much in line. Yeah.
Yep, absolutely. All right, so let's there. I did a final push just to get a couple extra people in. Looks pretty solidified on those. So let me tee you up here, and you can take it away from here, Ori.
Okay, excellent. Thanks a lot, Sterling, for the great introduction. Here on this slide, I'm just basically recapping the sentiment that you've mentioned, which is that service providers generally believe that SDN is a very interesting technology, it's the right technology, and they want to deploy it. The only question is when, right? And part of the challenges or part of the obstacles we're seeing, which may be slowing down deployment. It's not like everybody's deploying SDN today, right? So what's slowing them down is a few things, and these are the top ones that we heard from service providers. So one of the issues is standards. The service providers are used to working with standard solutions, and the standards for SDN are still not fully developed yet. The other question that people ask themselves is, okay, I understand the general value of SDN, but what's in it for me? How is it going to help my specific network? And perhaps the most important challenge, which again reflects back to the poll question, is am I ready for such a big leap? I mean, today I have a network that is running in one way. If you look at the SDN vision, it's going to run in a totally different way. How do I make such a big leap? And as we know, revolutions are scary, in particular when we talk about these very sensitive networks that are the core of the business of service providers, right? So we tend to look at the deployment of SDN not as a revolution, but rather an evolution that's a little bit like a road trip. What do you want to have on a good road trip? You want to have a good car that can drive you smoothly and overcome bumps in the road and be fun to use. And you want to enjoy the journey each step of the way. You're not just trying to get to a destination, but you want to enjoy every step of the way. What is the analogy of this to SDN deployment? So if you look at the evolution to SDN, the equivalent of a good car is a system that absorbs changes in a smooth way. You don't want to revamp everything every time that things change in the background. And the equivalent of fun in a service provider network is you want to see a return on investment. You want to see value at each step of the way. You can't wait for the last step to see value. Right? So if you look at how this ties into how SDN can be deployed, there's really two models for deployment, possible deployment of a multi-tiered or multi-layered hierarchical control system. You can start from the top or you can start from the bottom. Right? Starting from the top means that you start by deploying a multi-layer controller, which is, by the way, a simple process. It's just a piece of software that sits on a server somewhere in the network. It needs to obviously talk to the network, and it can do so initially by talking directly to the gear or to legacy management systems. And then later you add beneath that multi-layer controller, you insert the SDN controllers for the IP layer and for the optic layer. That's the top-down approach. The bottom-up approach is to start from the SDN controllers for one layer and then for the other layer. And then once those are working and providing value, then you add multi-layer control on top of that. So let's start by looking at the bottom-up approach. And with this approach, there's some challenges. And the challenges really have to do with seeing the value at the initial steps of the deployment. So let's start by looking at what happens when I deploy the IP controller. So I have an IP network. I'm deploying a controller. What am I getting out of that controller standalone, right, without multi-layer control? I'm getting some value because routing decisions become centralized now. I can use resources more efficiently. That's understood. But if I'm a sophisticated IP MPLS user, and I already have a well-developed MPLS traffic engineering TE control plane, then the value of centralization itself is not all that high. And we've seen some studies from some of our service provider customers that show about 10% improvement over an MPLS control plane. Now, if you're not a very sophisticated IP MPLS user and you just have a simple IP network, then SDN for the IP network provides you a lot of value because it gets you from a very inefficient network to a much more efficient network. But you can achieve a lot of that just by using existing mechanisms in the control plane of the IP layer. Okay, now let's look at the optical layer. What is the value of deploying an optical controller standalone without any multi-layer control? Now the issue is it's different. Optical networks have been managed centrally forever, right? From the beginning, they've been managed in a centralized way. So the fact that you've now centralized the control doesn't really buy you a whole lot. It's stuff that you could do with your existing management system. And indeed, the main issue with the optical network is that despite the fact that there are optical switches, ROADMs, in the network today, people don't use them a lot. They use them to set up connections, but it's not like you move connections around. It's a very static network. It's not agile. And the reason that it's not agile is not because of lack of controller. It's because these optical connections are used by the IP layer mainly, and you can't move an optical connection without losing traffic in the IP layer. The optical connection will disappear for a couple of minutes before it gets reestablished, and that's unacceptable without coordination with the IP layer. So the issue is really lack of coordination with the IP layer prevents agility in the optical layer. Again, I think this reflects one of the earlier slides that you've shown where IP and optical together make more sense to people. I think that's perhaps one of the main reasons for that. Okay, so the bottom-up approach has some issue with, in some cases, with creating value at the very first step. Let's see what happens when you look at the other deployment model, the top-down deployment model. Right? So with the top-down deployment model, to remind you, we're starting with deploying a multi-layer controller. So again, you put this piece of software on a server somehow that has connectivity to the management systems of the IP and the optical layer, or in some cases directly to the gear. Right? It can talk to, for example, to routers to a netconf, and that way it gets access to the network. And what can it do at this stage without controllers? And the first thing that it can do, which provides a lot of value in itself, is provide good visibility of the network. It's amazing when you look at some of these networks and you talk to service providers. It's truly the case that the IP guys and the optical guys have their own kingdoms, and they really don't understand much about the other network. And just putting those two networks together, accurately mapping how they're connected, which router port connects to which optical port, understanding which optical link, if it goes down, what IP links are affected by that. All that provides huge value to them just right there. And it's read-only, which makes it also, by the way, much easier to deploy. You have nothing to lose. You're not going to hurt your network through read-only applications. And what you can do with that, with read-only application, is start analyzing the network. There's a lot of data you're getting from both layers, and you can analyze different parameters of the network. Are they configured properly? Is the IP layer truly protected the way that the IP guys have intended it to be, or perhaps a lot of the IP links go through the same optical fiber that if it gets cut, you lose a lot of traffic. You can already get to start recommending how to optimize the network. Still, obviously, the optimization process might be still manual at this stage, but you can start understanding what would be a good way to optimize the network. You can start closing the loop from planning to deployment, which is today a bit broken. Right? The planning guys plan the network. it gets deployed in a certain way, but the planning guys don't have a direct feedback to understand whether the plan was executed as they expected. And therefore, the next planning cycle, the plan deviates slightly from reality, and that gets worse over time. So closing that loop, providing the planning guys with accurate understanding of the network is huge. Understanding how the connections are mapped, right? You know, an IP link, how does it go? Which optical path does it actually take? What are the shared risks I mentioned earlier of IP links, and that's something that you can feed into the IP control plane even, and say, well, here are the actual risks that these IP links have, and go in your MPLS layer, reroute diverse MPLS paths in a way that's truly diverse. So you can get a lot of value just by reading the network. And for that, you don't need very sophisticated controllers. The next step of our journey is to add an IP controller. As an example, I could have added the optical controller next, but let's start with the IP controller. So now the IP controller replaces the role of these management tools and replaces the need for the multi-layer controller to directly access the gear. And that makes it a lot easier to control a large network, because just accessing all the network elements is a complicated task, and keeping everything in sync. So having that SDN controller helps the multi-layer controller get better. It helps the multi-layer control have a more up-to-date and consistent view of the network. Another very important thing that you get from the IP controller is the traffic. And for multi-layer control, you do need to understand the end-to-end IP traffic to be able to analyze how the network will behave under changes. So getting that traffic is crucial from the SDN controller. And the third element, which is perhaps less known, and a lot of people don't consider it as part of the IP control of the SDN controller for the IP layer, is a what-if analysis tool. The multi-layer controller all the time needs to find ways to optimize the network. And for that, you need some tool that can, with high fidelity, simulate the behavior of the IP network and understand what happens if I add a new link between two routers, or if I remove temporarily some link to reroute its optical path, for example. So this what-if capability is a very important part of the, if you will, the control system for the IP layer. And that allows even the existing read-only applications to become more real-time. And it also opens the door for a bunch of, I call them semi-automated applications, which means applications that the operator is still in the loop, in the decision process, but otherwise the process is fairly automated. So, for example, alarm correlation. I can now understand if there's a failure. Should I send the IP guys to fix it or the optical guys? Because a failure in the optical layer will affect the IP layer in a major way, but it may not be something the IP guys can fix. So understanding that is much easier with multi-layer control. Coordinated maintenance is another good example of a semi-automated application and that's about, I'm an optical guy. I want to maintain some amplifier somewhere. It might take down a lot of IP traffic. I don't know that as an optical guy, and it's very hard. I need to put a lot of tools together to figure that out today. With multi-layer control, I can simply ask the multi-layer controller, well, what happens if I take this link down now? And the system will say, well, based on the traffic I'm seeing in the network and based on the impact that this optical maintenance will have on the IP layer, which obviously the controller knows, based on all these things, here's what's going to happen. You might have congestion somewhere or not, and that makes it much easier for the operator to start the maintenance activity and know that it's safe to do it at this point in time. A bigger problem is larger scale changes in the network. Understanding the impact of those, again, it helps a lot through multi-layer control, just by virtue of understanding all the parameters of the network. So the interesting thing to note is that the same IP controller that provided medium value, let's say, standalone, provides a lot more value when it's coupled with multi-layer controller, and therefore that value as part of the process is there. Okay, so we've added the IP controller, let's now add the optical controller. So when I add the optical controller, so again, replacing the use of optical management systems typically that you would need to use, without that controller. When I add the optical controller, again, a lot of things become more real time, more accurate. I get an accurate state of the optical network. I know about failures in real time. I know how everything is routed, and with that, I can already go to the next level, which is to start moving things around. So, namely, I can now define a new optical path, request it from the controller, and the controller will just set up the path for me, which is something that's fairly hard to do in today's system. Certainly not in real time. The other thing that you can do is reroute optical circuits. Like you have an optical circuit that goes one way. Let's assume it shares a lot of risk with other optical links, other optical circuits that support a bunch of IP links. I want to move some of the optical circuits to spread out the risk, to reduce the shared risk between those different systems. Again, something I can do with an optical controller, very hard to do without it. Just like I needed for the IP layer some tool that simulates the behavior of the network, this what-if tool, I need the same from an optical controller, and that's fairly common. In fact, most of the optical controllers provide that capability, and that's the ability to simulate the transmission in an optical system. So as a lot of you guys hopefully know, optical networks are analog. Right? It's very hard to determine if I can set up a connection from here to there. It depends on a lot of parameters, the fiber types along the way, other connections. It's not an easy problem, and every vendor solves this problem in a slightly different way. So I need the controller of the optical system to tell me, can I set up a connection from here to here? For restoration, for optimization, you name it. You need to be able to know what connections can be set up and how expensive these are. Maybe you can set up a connection, but it requires a lot of electrical regeneration, which is expensive. It may not be worth it. So all these questions can be asked of the optical controller. Now, what capabilities? So let me actually start with the second bullet. With all these capabilities that I just mentioned, the multilayer controller can start actively managing the network. So we're moving from a semi-automated solution that we had in step 2 to a fully automated solution. And a fully automated solution basically allows for closed loop operation. Like you see something in the network, it triggers some action on the multilayer controller. Then state of the network changes. Multilayer controller knows about the change. So there's a loop here that allows more tight control of the network. So what are some examples of applications that enjoy from that full automation, or that require that full automation in the system? The perhaps most famous one or most obvious one is multilayer restoration, and Sterling, you touched on that earlier. And this is one of the key applications that really enables significant cost savings from multilayer control. So here, if in the earlier steps there was some value for multilayer control, in this step you really get the big capex savings that are part of the promise of this whole solution. And this is achieved by basically exploiting optical switching in conjunction with restoration mechanisms in the IP layer to deal with failures. So if there's a failure, sometimes it should be dealt with in the IP layer. Sometimes the most efficient and cost-effective way to deal with it is by going around the failure in the optical domain. And actually, oftentimes you need both in different steps of the process. It's a fairly intricate process that allows you to get the network quickly to operate to a good state again, without any traffic loss, and but you want to do it in a very careful way, coordinating the two layers. So this is, if you will, one of the key values of multi-layer control. And for that, you need controllers in both layers. You need the real-time behaviors that both layers provide. Okay. The other application that provides also significant CapEx savings is multi-layer optimization. So here it's not about restoring quickly from failures, but rather looking at the long-term behavior of the network, at traffic trends, and understanding, well, the IP layer is not necessarily architected for the current traffic pattern. Perhaps it changed over time, or perhaps there's some significant event that causes traffic to flow differently from what it's expected. And multi-layer control looks at understands the issue through the IP controller. And then it starts using this what-if tool in the IP controller to understand what it can do to help the situation. And it might find that perhaps adding some link between two routers or adding more capacity on existing links between routers is the right solution. And this can be reflected and agreed upon by the operator, or perhaps long-term this can also be fully automated. It's a much slower process, but still automation and accurate execution of the optimization orders is key here. This is not something that a person could do without risk of breaking something in the process. If you will, the culmination of both optimization and restoration, if you put them together and you look at disasters, I don't know, a flood or some terrorist activity that causes multiple things to fail, routers, optical gear, perhaps data centers. That looks like an optimization exercise because you have now a network with less resources and you're trying to get to make the most out of it. But it's an optimization problem that requires fast action. You don't want to wait, many days for the disaster recovery plan to kick in, and that's a perfect role for this overall control system, the SDN controllers at each layer, as well as the multi-layer controller. And finally, the final example I'm giving here is what I call Cloudera bandwidth on demand. So I'm trying to provide connectivity to data centers. I'm trying to provide it on demand because they don't need it all the time. But we're talking about a lot of capacity, tens of gigs of traffic flowing between data centers, and that's something that you don't want to reserve just for the chance that the customer might need it. That won't be economical for the service provider. If both layers work together, this can be achieved. So this was step 3. So we talked about a lot of things, a lot of value that can be added by having multi-layer control with controllers at both layers. Let's move now to the fourth step, which is a bit, in my opinion, at least a bit further out, and that has to do with changes beneath the controllers. So now we're talking about replacing legacy routers and perhaps even legacy optical gear with white boxes. There's a lot of discussions about it, open ROADM initiative, white boxes to replace routers, and it remains to be seen which of those will make it and which of those will make sense. But I'm assuming that some of them will make sense, and this would be a step that you can undertake more easily when you have the whole control system on top supporting you, because you have a system that still has your legacy network elements and some new white boxes, and you want something that allows you to slowly transition traffic from one to the other, and multi-layer control is perfect for that. It can kind of orchestrate both layers to kind of gradually move functions and capabilities and services from the legacy to the new gear. And in fact, this is true even without white boxes. Just moving to a new generation of optical gear, flex spectrum optical gear, for example, which is coming, is much easier if you have the whole control system supporting you and allowing you to do that in a gradual and in a very controlled manner. Okay, so this fourth step, if you will, the full kind of vision of SDN and NFV, according to the definitions we just heard, and it gives you deep control of the network behavior, much more detailed control than with legacy gear, and there's a hope of reduced equipment costs by working with white boxes. But again, the multi-layer control system on top stays unchanged. It's pretty much same control system with added capabilities over time to support those the change in the hardware below the control system. Okay, so this was the if you will a four-step journey towards full deployment of SDN. And I think the key point I was trying to make here is that this process can be gradual, and you can see value at each step of the way, and therefore you don't have to. And by the way, you don't have to go all the way. You can stop at step 3, and you still get enough. You can still get value, right? It's not like you're forced to go all the way to the end of this road to see the value. Now so far I talked about planning a journey with some nice stops along the way, right? Let's now talk about the car, or specifically the shock absorbers of the car. So one of the key concerns is standards, right? There's no standards yet for SDN. There's a lot of standard bodies working on it. There's some proposals, but they're not quite there yet, right? So how do I deploy something today and make sure that whatever happens, I don't need to now start revamping a lot of my my management systems and orchestration systems, because as I've shown here in the picture, multi-layer control will to a large extent work not just with its own native applications, but it will feed those management orchestration planning systems that today are fed by inaccurate information on a rare basis. Instead, they will be fed by accurate real-time information. So how do I make those changes, for example, in standards without affecting the top layer here? Okay. So it turns out that with this control system that we've drawn here, we have actually multi-tiered shock absorbers. For example, if you replace legacy gear with new gear, white boxes or not, it doesn't matter. Then all that has to change is the gear itself and the SDN controllers of that gear. If standards exist, then these new SDN controller and the old one will have to use the same standard, and multi-layer control doesn't have to be changed much. On the other hand, another likely scenario is that the northbound interface from those controllers will actually change because, for example, the standards have started appearing and people want to migrate the standard solution. In this case, the multi-layer controller will have to change in a very limited way. The multi-layer controller consists of adapters that talk to the SDN controllers, the various SDN controllers, and these adapters will have to be changed. You'd have to add another adapter that supports, standard X. And the way that the multi-layer control system is built, is that there's a very clean-cut separation between the adapters below, the data model, which houses the current state of the network, and the applications on top. The applications just look at the data model. They understand the network through the data model. And therefore, if an adapter changes below, the language that you talk to a controller changes, it's immaterial. The applications don't even know that, even if they wanted to. So it's clear it doesn't affect the applications, and it doesn't affect the northbound interfaces from the multi-layer controller to the management and orchestration system. So you have, to summarize this slide, you have both controllers and the architecture of the multi-layer control system as shock absorbers that allow you to change equipment, change interfaces, and do all that without affecting the operation of the service provider network. Okay, so this I believe addresses the concern about standards. I think there's a lot of you hear it especially from the new kind of large network providers, the Googles and Facebooks of the world, who say, look, yeah, standards are good, but let's just go do something. We'll learn along the way and add standards, and that will help us improve the standards, and then we'll deal with it later. It's not that you don't have to wait for a standard before you start acting. Okay. Let me kind of try and summarize what I've said so far. So first, multi-layer control provides significant value to service provider networks. I think that's fairly well known, but still we looked at value in terms of CapEx savings at both layers, by the way. When you restore IP traffic in a more efficient way. You save on router port as well as transponders. So both layers are helped by that. You have a safer and simpler operation because you don't have now complex procedures to get the optical guys to understand what the IP guys want and vice versa. And there's not as much human error in that process. So the whole operations processes become much safer and simpler. You improve the availability of the network. You can deal with large-scale disasters that today, honestly, there's no really good solution for them, and certainly not much automation. And you enable new sources of revenue, cloud era, high-speed services that you can't really build very cost-effectively without using both layers. So this is in terms of the value, but perhaps as important is not just what the value is, but how you can get there in an easy and gradual fashion. And I tried to articulate that first, the control system, multi-layer control, the SDN controllers of the single layers below multi-layer control, those are easy to deploy. They're ultimately a centralized piece of software that sits in one place, gets upgraded at once. You don't have a problem where half your network uses an old version of the software and half of it uses a new version. It's just, that's the beauty of centralization. So it's very easy to deploy. The deployment process is safe because you start from read-only applications. You can get to full automation, but you can do that at your own pace. You're not forced to make any step in this process before feeling confident about the solution so far. And again, that's perhaps in contrast with deploying new gear, where you kind of can do a little bit of testing, but at some point you put the gear in the ground, and if things are bad, it's very hard to deal with it. Here, it's because it's a centralized piece of software that sits in one place, much easier. Right. Now, I hope I articulated the clear value that you get at every step of the way. I've shown two deployment models. There's obviously others, and there's more details that can be discussed, but probably not today. But it's key to have, and we believe that there is a way to get value at every step of the way. And you don't need to wait for standards. Standards will happen. It'll take a few years. We have the emergence of standards now, which is a very good thing. So we're starting to see at least parts of the solution being standardized, but perhaps not the full solution. And that's okay, because you can start deploying and you can move to those standards when you feel you are ready for them and they are ready for you. And you can do that in a seamless fashion using these shock absorbers. Okay, finally, the image I want to leave you with is this image of on the left, the dilemma that the service provider has. They love SDN. They know there's a big trophy on top, but how do you climb there in one step? How do you change your operation? We believe that a more realistic path is an evolutionary path, small steps. At each step, you want to have a small trophy. You want collective trophies along the way. And at the end, you're going to get to the same place, but you're going to get there in a way that where you've learned along the process. You felt confident on each step before moving to the next step. We believe that's the right model for SDN deployment. So with this, I'll finish my part.
Okay, excellent. Yeah, so let's, great job, Ori. So let's move over. So we're just about to go into the Q&A. In fact, we'll probably get it started while this poll question is up. So the second and final poll question should be up in front of everybody. And that question is, what is the main benefit? So first question was about challenges. This is, what is the main benefit you see from deployment of multi-layer control? Ori had walked through a number of them, so we're curious what you think is resonating most. CapEx savings due to multi-layer restoration and optimization, simplified and lower cost operations, is it enablement of new service, or is it transformation of the organization? And we'll give a moment for responses to come in there. While we do that, let me move to the Q&A There was a question, Ori, that last slide you showed the stepped approach. It was kind of a good graphic describing what you had walked through. There was a question about the white box, which is the final step in that migration you'd walked through. The question is, do you have to go to step 4 and deploy the white boxes? For operators that may not be interested in that approach, is that do they need to go there at some point, or kind of what are you hearing from the service providers you talk to? How much is that step 4 important versus maybe going up to step 3 only?
Yes. I think I'm hearing mixed opinions. I think service providers are certainly curious about white boxes. The promise of cost savings is certainly, tempting. But at the same time, at least in the parts of the network, in the core and the metros of the network, I think there's a wait-and-see approach. It's not high on their. They're afraid to do it, soon. It's not high on their list. I think that steps 1 to 3, they understand that provides a lot of value in its own right. You don't need to go to step 4 to get, for example, a lot of the CapEx savings. Step 4 will perhaps give you further CapEx savings if this direction succeeds. But there's certainly not a consensus, as far as I've seen, on necessarily going to white boxes.
Okay.
Have you seen anything different, Sterling?
Well, the white box trend is quite new. So we've got some operators are quite interested in it. AT&T for sure. But there are still a lot of operators that aren't sold on it yet. So we're waiting to see how that plays out over time. But it's definitely, of the trends we're looking at, that's the newest of them within optics. So it hasn't quite taken off yet.
Yeah.
So that doesn't. So we've got the poll results up here. Take a look. Let me do a last push, but I don't think it'll change. So yeah, simplified and lower cost operations is the primary benefit, 44%. And then the CapEx came in second at 24%, and then the other ones fell off from there. Same question to you that I typically ask. Any surprises on those results? Did you expect the operations to be the biggest benefit?
That's actually very interesting. When we started working on multi-layer control, my assumption was that the CapEx savings are the compelling reason for moving to this, because you can save. You've shown in your models, you can save half the cost of the network. How more compelling can it be, right? But as we spoke to more and more operators, we saw that indeed simplifying operations in their mind provides perhaps more value, because the cost of operations, and that's something that's hard to quantify. CapEx is easy, right? You count number of ports, you multiply it, but quantifying operation cost is hard. And they understand that the cost of operation is actually much higher than the CapEx that they put in the network. And therefore, this kind of reflects. I would have been more surprised, let's say, a year ago about the result, but now it's actually in line with some of the more recent discussions with customers. Very interesting.
Right. Yeah, no, and just on the points I had made in my opening, that the CapEx operators can quantify. You can stick a number to it, so they do that, but. Even in the case of Telefonica and Deutsche Telekom, I don't think they necessarily thought that CapEx certainly wasn't the only benefit, and I'm not even sure they would have felt it was the main one, but they could quantify it, so they did it. We got a lot of questions coming in, so let's start hitting some of these. You had shown, this is from an operator, you had shown on one of your slides, Cloudera bandwidth on demand, and the question is, what's the specific feature of Cloudera bandwidth on demand compared to previous iterations of bandwidth on demand? What's different about the cloud?
Yes. The main difference in my mind is that when I say Cloudera, I mean Cloudera bandwidth on demand. I mean very high speed bandwidth on demand. It would imply a few tens of gigs, if not hundreds of gigs, of capacity that is needed for some data center to data center operations. Kind of the normal bandwidth on demand, if you will. Yes, I need a VPN or I need some connectivity, but it's in the order of maybe a few gigs. And there's a fundamental difference between the two, because if I just need, a couple of gigs from here to there, I can easily absorb that in the capacity that I already have in my IP layer. I just need to set up the connectivity and everything is fine. But if I need 100 gig worth of capacity, all of a sudden the service is at the same granularity as the IP layer chunks themselves, and that is not something that you can build for efficiently in one layer. Like you would need to overbuild the IP layer too much to support such high-speed bandwidth on demand, and that's where you need multi-layer control. So good question.
Okay. Yep, excellent. Next question, and this was from early on in your presentation, but you had talked about not much value in centralizing the IP domain versus traditional IP. So the question is, I'm not sure why you say that there isn't much value in centralizing IP domain. Without doing that, how can you optimally construct inter-area or inter-domain LSPs?
Yes, that's a very good question. I was focusing really on one domain when I specifically talked about this. Within a domain, the construct, the control plane construct that exists today, especially traffic engineering, are fairly well developed. When it comes to dealing with managing capacity across domains, the control plane is challenged even today. So I would agree that when it comes to, for example, dealing with LSPs that go across different domains inside a service provider or even between service providers, then centralized control adds value independent of our discussion today.
Okay, excellent. Next question. We're getting close to the hour. Maybe we'll run a couple minutes over, but we'll see what we get through. Question is, do you keep running traditional routing protocols in the IP cloud, or is it fully managed via MLC, including path calculation and signaling? MLC, I guess, multi-layer control.
Yes.
Yeah.
We are very careful, and I think it's important when you architect the solution to make sure that the boundaries are clear. Everything that has to do with how the IP layer manages its own resources, in my mind, is part of the role of the IP controller. That's not something that multi-layer control needs to get into. Multi-layer control plays on the boundary between the IP layer and the optical layer. Namely, it can add capacity to routers, remove capacity from routers, between routers, and reroute optical connections. I'm absolutely assuming that it's certainly initially in step one, or step two, traditional routing protocols are kept intact. There's no need to change it. You can if you want to, but you don't need to change it for multi-layer control. Multi-layer control is not going to intervene at that level of detail in the IP layer.
Okay, great. For everybody in the audience, there should be a survey link up there. If you could just take a moment to fill that out. That's how we improve our webinars over time. So let's see. We've got a question. How do you manage the transition of SDN controller to legacy network with minimum risk? I'm wondering if maybe it's SD from a legacy network. I don't imagine you're going from an SDN controller to a legacy network, but I guess the read would be, how do you manage from a legacy network with minimum risk? Any thoughts on that? You kind of addressed steps, but maybe you can elaborate.
That's for step 4. That's the toughest step because doesn't involve just installing one piece of software in one place. So I don't have any magical solution for that. The only thing I can say is that in terms of the whole control system, how everything is controlled and managed together, the operator will not have to feel any change in how the network is managed. But certainly there is risk in deploying boxes. You have to do it very carefully whenever you deploy new boxes. I mean, that we can't help much with, right?
Right. This may be the last question. Let's see how it goes. This relates to, the question is there a risk that emerging standards will require revamping the multi-layer controller? And I guess I would tack onto that my own question, which was, you had mentioned the companies like Google, the web scale companies, urging to move forward without standards and figure out standardization down the road. I'm wondering how that's resonating with the Tier 1 network operators. So maybe kind of two-part. Can you address the question of the risk of emerging standards requiring revamping, and then how is this do it now, standardize later? How does that resonate with Tier 1s?
Yes. So on the first part, we don't see any risk of standards kind of requiring you to revamp multi-layer control, primarily because these standards are concerned with getting information from the controllers into the multi-layer controller, and that, whether you do it one way or the other, it doesn't change the fundamental applications, that the multi-layer applications that run on top. Anyway, we're very aligned with emerging standards, so but I don't see any risk of that happening. Now, to your second point, I'm seeing more and more openness in service providers to consider new approaches. I mean, open daylight, the open source approaches, right? As an example, and I think they understand that to be competitive, they have to move faster than before. They don't have the luxury to wait, 4 years now for standards to be fully done and start deploying them. I'm seeing a lot of openness, at least in some of the service providers.
Interesting. Yeah, it's a trend we're starting to follow as well, so I agree with that. On that, we are past the hour, so we're going to need to close out here. There are questions we didn't get to, but I'm sure Ori will follow up individually after the conference ends to address some of those. Again, thank you to the audience for tuning in. Thank you, Ori and Sedona, for this great information. Thanks, everyone.
Thanks. Pleasure. Okay.